learners, thank you for tuning in again for our math literacy class on representing data. The focus is on a bar and a histogram. Did you know that the Department of Education uses different types of graphs to analyze learner performance statistics in any grade and any given subject? For an example, there we are given the bar graph there that indicates the performance in 1970, the performance in 1990, up until the year 2022. At the end of this lesson, you should be able to plot a bar graph, analyze a bar graph, plot a histogram, group data according to different intervals, and identify a variable as well as analyze a histogram. We're going to look at representing data, so the focus is going to be on a bar graph as well as a histogram. You should know how to classify data and summarize data. Okay, question 1 on the pre-knowledge practice says, classify the following as categorical or numerical. If numerical, specify whether it's a discrete or continuous. Question 1A, the number of learners in a class. Number of learners in a class can be counted, so it's based on numbers, so it is numerical. But remember, our instruction clearly stated that if it's numerical, then you have to specify whether it's a discrete or continuous. So what type of numerical data is this? It's going to be discrete because it can be counted. Number of learners can be counted. So it is the discrete numerical data. Then question B, the height of the learners in a class. The height of learners, height is also a value, it's a number, so it is still numerical data. But what kind of numerical? It is the continuous, because height cannot be counted, but it can be measured. So it is continuous. Then C, the eye color of learners in a class. The eye color, so eye color cannot be numerical because you don't measure the eye color, you don't count the eye color, but you classify it according to categories. So it means it's categorical data. So it's categorical data. Then the speed at which a car is traveling. Speed can be measured but not counted. So it's still values. So it means it is numerical but continuous. Then we move on to the next question. A group of learners kept a record for their shoe sizes. Here is their shoe sizes. How many learners form this group? So we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 learners that form this group, and then calculate the mean shoe size. Though these are the shoe sizes, so mean, it means we say mean is equals to the sum of all the values there. So it means sum of all the shoe sizes. We've got shoe size 1, 2, plus 3, plus 4, plus 5, plus 6, plus 7, plus 8, plus 9, plus 9. So in total, you must have 10 values. So let's count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it is the sum of all the values divided by the number of the values. How many values are there? We've got 10 values in total. Then we do the calculation. So 1, let's do it together. We will say 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 9. Then you make sure that you punch the correct values on your calculator so that you get the correct answer at the end. Divided by 10. So that sum is 54 divided by 10. What is 54 divided by 10? It gives us 5.4. So it means the mean value is 5.4. Then question C says, determine the median shoe size. Median shoe size, it means you have to first arrange your data set in ascending order. So if we check already, our data set is given in ascending order because we've got our lowest value there, our middle value, and we don't have any other number that is larger than the other part before it. So it means our data set is 1, then it's 2, it's 3, 4, 5, 6, 7, 8, 9, and 10 following each other like that. So median, it is the middle number. So when you find the middle number, you have, when you put a number aside on your left hand side, you also do the same on your right hand side. So we've got 1, 9, we've got 2, 9, we've got 3, 8, we've got 4, 7. So we are left with 2 values, which means that the number that we are looking for is actually in between these 2 values. So then how do we then calculate it? We will say median is equals to 5 plus 6. Why do we add? Because the value that we need will be the sum of these 2 divided by 2, because there's 2 of these values. So we divide it by 2. So what is the middle value? So what is 5 plus? 5 plus 6, it gives us 11. 11 divided by 2 will give us 5.5. So it means the value we are looking for is in between these two values, which is 5.5. Then the new words that we're going to look at, we're going to define a bar graph. A bar graph is defined as a graph that shows the frequency of one data value per category by means of bars used for discrete categorical data. Then it means the data that can also be counted. For an example, we are given the bar graph there with the nicest fruit. We have the number of people and the different fruits that are given there. So we've got an apple with 35 people that say an apple is the nicest fruit. We've got a blueberry with 40 people saying it is the nicest fruit. Then a histogram, it is a graph used to display continuous data. So with a histogram, we will display it using continuous data. For an example, we are given the continuous data, which is the data that can be measured. We are given the height now. So this height, we are looking at the heights of the black cherry trees. These are the heights, and we have the frequency. How many black cherry trees are having a height that is 60 to 70? We've got about 3 of them because it is in the middle of 2 and 4. Then class intervals. Class intervals, we define them as subdivision of data into intervals or groups, which each class interval having the same width in order to be comparable. So we are comparing things that are the same. So that is why we are talking of same width. So for an example, we've got a class intervals of 10 data points. So 10 data points, it means from 10 to 19, we've got 10 values. From 20 to 29, we've got 10 values as well. Then the next word is frequency, which is defined as the number of times something happens or appears. So for an example, the frequency of the color blue is 37%. So it means out of 100%, the color blue, where do we see your color? You see it where it says, where the axis says colors. So blue is there. So blue is represented by 37%. Let's take a quick break and then we'll continue afterwards.